First we will write some important concepts, then we will execute this concept problem by problem. Very, very important topic, quadratic equations. It's an equation of degree 2. It's an equation of degree 2. The generic form of the quadratic equation will be ax square plus bx plus c equivalent to 0. It's an equation of degree 2. The generic form of the quadratic equation will be ax square plus bx plus c equivalent to 0. In case if it is not equated with 0, this will become a quadratic expression. Any expression when equated with 0 becomes an equation. So ax square plus bx plus c, this I can write it as x square plus b by ax plus c by a. So this it will be a into x square minus or minus into b by ax plus c by a. A into x square minus of minus b by a is nothing but the sum of the roots. C by a is nothing but the product of the roots. Now, if the degree of the equation is 2, you can write it as a into x minus alpha, x minus beta. Ax square plus bx plus c can be written as a into, if I further simplify this, this will be x minus alpha into x minus beta. For degree 2, it is written as a into x minus alpha into x minus beta. Similarly, if the degree is 3, ax cube plus bx square plus cx plus d equivalent to a into x minus alpha, x minus beta, x minus gamma. Similarly, if the degree is 4, a into x minus alpha, x minus beta, x minus gamma, x minus some other root. Now, in the equation ax square plus bx plus c, this is a quadratic expression. This is a quadratic expression. If this quadratic expression is equated with 0, then it becomes a quadratic equation. Quadratic equation. So that will become ax square plus bx plus c equivalent to 0. Now, in ax square plus bx plus c, sum of the roots will become minus b by a. Product of the roots will become c by a. Difference between the roots will become mod of root of b square minus 4ac by a. Sum of the roots, product of the roots and difference between the roots. Ax square plus bx plus c, sum of the roots, product of the roots. In the quadratic expression ax square plus bx plus c, sum of the roots and product of the roots. Sum of the roots will be minus b by a, product of the roots is c by a. Now here, if two roots are same but opposite in sign, then b will be equivalent to 0. Please write down that point. b is 0, roots are same but opposite in sign. If b is 0, roots are same but opposite in sign. Roots are same but opposite in sign. If alpha equivalent to 1 by beta, c equivalent to a, because alpha beta will become 1. Another important point, c equivalent to a if the roots are reciprocal to each other. If the roots are reciprocal to each other. If the roots are reciprocal to each other. If the roots are same, opposite in sign, B will be equivalent to 0. If the roots are reciprocal to each other, C will be equivalent to A. C will be equivalent to A. Next one. If alpha equivalent to beta, B square minus 4AC. Now, here very important point. In the quadratic expression, A cannot be equivalent to 0. If A is equivalent to 0, this will become a linear. A should not be equivalent to 0. If alpha equivalent to beta, B square minus 4AC is 0. In this case, roots will be real and equal. Roots are real and equal. Roots are real and equal. Quadratic equation is an equation of a degree 2. The generic form of a quadratic equation will be ax square plus bx plus c. A not equivalent to 0. Sum of the roots will be minus b by a. Product of the roots is c by a. Difference between the roots. Why these modulus? Alpha could be greater than beta or beta could be greater than alpha. If b is equivalent to 0, roots are same but opposite in sign. If c equivalent to a, roots are reciprocal to each other. Roots are reciprocal to each other. Side heading. Discriminant. First 10 minutes we will discuss some important theory, then we will apply the theory. This third point is a very important point. It can be extended to another degree also. When an expression is equated with 0, then the expression becomes an equation. Expression equated with 0, then the expression becomes an equation. Next, side heading. Shall I discuss?
Yes.
Discriminant. Discriminant of a quadratic expression. Discriminant of a quadratic expression. Discriminant of a quadratic expression. The discriminant of a quadratic expression is given by b square minus 4ac. This value can take any one of the three values. It could be equivalent to 0, it could be greater than 0, it could be less than 0. If b square minus 4ac is less than 0, roots are imaginary. When I say roots are imaginary, that means you cannot plot the roots onto a number line. Imaginary values cannot be drawn on a number line. Cannot be drawn on a number line. B square minus 4ac equivalent to 0. Equivalent to 0 means real and equal. B square minus 4ac equivalent to 0 means roots are real and equal. Greater than 0 means real and unequal. Real and unequal. Real and unequal. Again, two values are there. B square minus 4ac is the discriminant, so I call it as B. If this B value, if it is a perfect square and greater than 0, this will be rational and unequal. if the discriminant is not a perfect square, if D is a non-perfect square, this will become irrational and unequal. Irrational and unequal. B square minus 4AC, it can be equal to 0, it can be greater than 0, it can be less than 0. Please remember, this is the discriminant for a quadratic expression. You might get it out. What might be the discriminant for a cubic expression? That also we will discuss. Equivalent to 0, greater than 0, less than 0. Less than 0 means roots are imaginary. Imaginary roots cannot be drawn on a number line. Equivalent to 0 means roots are equal. Now what we will do is, we will take one example quadratic equation to understand. Suppose, example, x square minus 4x plus 13 equivalent to 0. X square minus 4x plus 13 equivalent to 0. Discriminant will become b square minus 4ac. 16 minus 52 minus 36 less than 0. That means roots are imaginary. Right? Here also an example. X square minus 4x plus 4 equivalent to 0. Discriminant is b square minus 4ac. 16 minus 16, 0. Discriminant 0. This nothing but x minus 2 whole square equivalent to 0, x equivalent to 2. There are two roots which are equal to each other. The two roots are 2, 2. This is x square minus 4x plus 1 equivalent to 0. What will be the discriminant? B square minus 4ac. 16 minus 4, 12. 12 is a non-perfect square and greater than 0. This is x square minus 5x plus 6 equivalent to 0. So this will become b square minus 4ac. D is 1, which is greater than 0. 1 is a perfect square. So that means quadratic equations will be given and he will ask you what is the discriminant of a quadratic expression. What is the discriminant? Discriminant can be calculated by using the value b square minus 4ac equivalent to 0, greater than 0, less than 0. Are you all? Note. Another note. This is a very important note. If an equation is a cubic equation, ax cube plus bx square plus cx plus d equivalent to 0. Ax cube plus bx square plus cx plus d equivalent to 0. Now, before writing this note, let us write another important note. See here, ax square plus bx plus c equivalent to 0. Very important second note. Only when the coefficients are rational, if one root is p plus root q, then other root is p minus root q. Then other root is p minus root q. Only when it is not always that if one root is 3 plus root 2, another root will be 3 minus root 2. That condition is true only when the coefficients are rational. Please put a star mark on the second point. Blindly don't substitute. If one root is 3 plus root 2, another root is 3 minus root 2. Ax square plus bx plus c equivalent to 0 only when a, b, c are rational. Then only if one root is p plus root q, another root is p minus root q. So for a cubic equation, if a, b, c, d are rational, there are two conditions that will come. If there is one imaginary, its conjugate will come, and rational, or all the three will be real. all the three will be real. Very, very important point. B square less than 2AC is the condition for the roots to be imaginary in cubic equation. I will also discuss this proof as the class proceeds. B square greater than or equivalent to 2AC is the condition for the roots to be real. B square less than 2AC is the condition for the roots to be imaginary in a cubic equation. Other than less than, what is remaining? Greater than or equivalent to. B square greater than or equivalent to 2AC is the condition for the roots to be real for a cubic equation. These two key points are very, very important. Only when the root coefficients are rational, if one root is p plus root q, another root is p minus root q. For cubic, how to check whether all the three roots are real, or how to check if two imaginary are there. Discriminant not.
So what's the meaning of rational?
Rational means, suppose if I take an example of x square minus 7x plus 10 equivalent to 0. What is the coefficient of x square? 1. 1 is a rational number. 7 is also a rational number. 10 is also a rational number. So that means rational number is not only an integer value but also takes a fractional value. Rational number is a combination of integers and fractions.
But then we told you irrational and equal for d is when it's not perfect square.
No,
Then 12 we got it
that is for what?
when
If a d is a rational, if the value of d comes out to be rational and unequal, then the roots are real and unequal. What are we talking about here? We are talking about the coefficients of.
yeah. But the 12 which we got here in your example, that was a rational number only, no sir? 12 is greater
Which
than
one?
0. X square minus 4x plus 1 is equal to 0, the example which we took.
Yes,
was.
12 is a non-perfect square.
It's not perfect square, but it's a rational number.
It's a rational number.
We
What?
got irrational and unequal.
What is this irrational and unequal? This is for what? Roots. These are all for the roots. This discriminant helps us in telling about the nature of, I think I wrote here, roots are real and unnatural. Here roots. This is also roots. This is also these. We are talking about the roots. Right? Next. Sidetic. Graphs for quadratic expressions. Very, very important. Graphs for quadratic expressions. Graphs for quadratic expressions. Graphs for quadratic expressions. Graphs. Graphs for quadratic expressions. Now see here. Quadratic expression. Graphs are only drawn for expressions, not for equations. Quadratic expression ax square plus bx plus c. Case 1. If I take case 1, a is greater than 0. D is also greater than 0. Case 1, a greater than 0, b greater than 0. Suppose if I take an example, x square minus 7x plus 10. If I decompose, this will be x minus 5 into x minus 2. If I equate it, what are the roots I will get? 2 comma 5. That means the equation will be like this. Quadratic expression shape will be in the form of a parabola. Either this or the inverted one. We will write one point. The shape of quadratic expression. The shape of quadratic expression. The shape of quadratic expression will be in the form of a parabola. The shape of quadratic expression will be in the form of a parabola. The shape of quadratic expression will be in the form of parabola. Will be in the form of a parabola. This is alpha, this is beta. Why it is touching 2 points? Because if I equate it with 0, I will get 2 points. X equivalent to 5. A greater than 0, B greater than 0. We will also discuss about the maximum minimum. Case 2. A greater than 0, D equivalent to 0. A greater than 0, D equivalent to 0. So this will be x square minus 4x plus 4. So this will be x minus 2 into x minus 2. D equivalent to 0 means the roots will be real and equal. That means both are equated. X, if it is equated with 0, x equivalent to 2. That means it is touching the axis only at one point, alpha and beta. If the graph is touching the axis only at one point and it is going upwards, a greater than 0, d equivalent to 0. Case 3. X square minus 4x plus 13. Case 3 is a greater than 0, d less than 0. A greater than 0, d less than 0. Now, if you observe the position of the graph, one it is down, next it is moving upwards, next it will further move upwards. If I further move upwards, what it will be? This will be like this. That means d less than 0. D less than 0 means roots are imaginary. Does imaginary points, will it touch the axis? No. So, now another important point. In the first quadrant, x is positive, y is positive. So, if I call the quadratic expression as y is ax square plus bx plus c. This y will be greater than 0. Y is greater than 0? Y is greater than 0 only if a is greater than 0 and d is less than 0. Very, very important point. A quadratic expression is greater than 0 only if a is greater than 0 and d is less than 0. Both the conditions are true. If a quadratic expression is greater than 0, a will be greater than 0, d will be less than 0. If a greater than 0 and d less than 0, quadratic expression will be greater than 0. Quadratic expression will be greater than 0. All these three cases are when a is greater than 0. If a is greater than 0, the graph is going upwards. The graph is going upwards. Please write down that point also. A greater than 0, the graph is going upwards. Now, please see here. If the graph is going upwards, what can you determine? Minimum value you can determine. Minimum value you can determine. Can you determine the maximum value? No. If a is greater than 0, graph will have unique minimum value. Graph will have infinite maximum value. Please write down that point. First point. The graph is going upwards. If a is greater than 0, the graph is going upwards. A is greater than 0 means the graph is going upwards. Another point. If a is greater than 0, the graph will have unique minimum value and infinite maximum value. If a is greater than 0, the expression has unique minimum value and infinite maximum value. unique minimum value and infinite maximum value. Unique minimum value and infinite maximum value. Now, please see here. The graph may not be like this. Depending upon the values of x, it can go like this. This can go from here to here. This can also go from here to here, right? And this can also go from here to here, right? B less than 0 means graph will not touch the axis. B equivalent to 0 means touch the axis at one point. B greater than 0 means touch the axis at 2 points. Right. Next, second. We did the graph for A greater than 0. Now we will do the graph for A less than 0. Less than 0. Let us not write examples. Once it is clear to you, then case 1, case 2, case 3. Case 1. A is less than 0, B is greater than 0. A less than 0, D greater than 0. The graph will be like this. D is alpha, D is beta. A less than 0 means graph will be a downward graph. Case 2. Case 2.
Sir, A less than 0 will have positive roots also.
A less than 0 might have positive roots. Suppose you see this graph, to the right side of x-axis alpha is positive, beta is also positive. Suppose if it goes like this, if the graph is like this, alpha is negative, beta is positive. If it goes completely to the left side, alpha and beta both are negative. So it really does not matter whether A less than 0, alpha and beta will be positive, they both. A less than 0, D equivalent to 0. B is case 3. A less than 0, B less than 0. D less than 0. A less than 0, D less than 0. If you observe the fourth quadrant, plus plus, minus plus, minus minus, plus minus. Very, very important learning. Y is ax square plus bx plus c. It is less than 0. It is less than 0 only if A is less than 0 and D is less than 0. Ax square plus bx plus c less than 0 only if A less than 0, D less than 0. See, simple way to remember that D is always less than 0. Expression will be greater than 0 if A is greater than 0. Expression will be less than 0 when A is less than 0. D will always be less than 0. If this is greater, this will be greater. If this is less, this will also be less. Next, write down note. For a quadratic expression, first note, for a quadratic expression, ax square plus bx plus c, ax square plus bx plus c, if A is less than 0, the graph will have unique maximum value. The graph will have unique maximum value and infinite minimum value. Graph will have unique maximum value and infinite minimum value. All these 6 graphs are important. We will solve at least 5 to 10 questions based on graphs. Case 1, case 2. Side heading. Next, write down. maxima and minima for quadratic expressions. Maxima and minima for quadratic expression. First write down this point, then I will give ax plus ax square plus bx plus c. If I call it as y, the minimum value will be at x equivalent to minus b by 2a, and the value is minus d by 4a. It will have minimum value when a is greater than 0. I will prove it right now. Already we discussed that if a is greater than 0, the graph is an upward graph. It will have a minimum value. At a particular value of x, it will have a minimum value. That particular value is minus b by 2a, and that expression minimum value is minus d by 4a. D is b square minus 4ac. D is b square minus 4ac. D is b square minus 4ac. Ax square plus bx plus c. If a is less than 0, y max will be at x equivalent to minus b by 2a, and the value is minus d by 4. Y is ax square plus bx plus c, a less than 0. Maximum value, values will not change, only whether it is minimum or maximum depends upon a value. A is greater than 0, it will have a minimum value. A is less than 0, it will have a maximum value. Less than 0, it will have a maximum value, b square minus 4ac. Proof. How you got this one? Proof is ax square plus bx plus c. This it will be x square plus b by ax plus c by a. This I can write it as a into x plus b by 2a whole square plus 4ac minus b square by 4a. If you simplify it, you will get this one, a into x plus b by 2a whole square plus minus d by 4a. If you simplify this equation, you will get it a into x plus b by 2a whole square plus minus d by 4a. See here, listen. If a is greater than 0 means positive, square function will always be positive. Positive into positive, positive, positive plus something, the value is increasing. If x is minus b by 2a, this will become 0. What is the minimum value? Minus d by 4a. If a is less than 0 is negative. Negative into positive is negative. Plus this value minus negative is less than 0. This minus, the value is coming down. If the value is coming down, this will become a maximum value. Problems based on graphs. Type 1. Problems based on graphs. We will solve a very, very important type in quadratic equations at the beginning. Problems based on graphs. Please write down the questions. First one. If f of x equivalent to ax square plus bx plus c, then a less than 0, b square less than 4ac, c greater than 0, a comma b are of opposite sign. These 4 options are given and the graph is also given like this. The graph is also given like this, alpha and beta. How many options are always true? How many options are always true? Every problem that we are discussing today is very, very important. How many options are always true? How many options are always true? If f of x equivalent to ax square plus bx plus c. Now see here. One by one we will discuss. Please see here. Listen carefully to this problem. First hint. Alpha and beta both are positive values. The graph is going upwards. If the graph is going upwards, a will be greater than 0. A is greater than 0. But first option is a less than 0. It is incorrect because the graph is going upwards. Second, b square less than 4ac. B square less than 4ac means roots will be imaginary. Imaginary roots, can it touch the axis? No. That means second also is incorrect. Are you all with me? Next. Third and fourth we will see. Now we will see how many options are always true. Sum of the roots is minus b by a. Product of the roots is c by a. Now listen carefully. Alpha and beta both are on to the right side of the x-axis. Positive. What is positive? Positive, this will become positive. A is nothing but graph is going upwards. A will be greater than 0. That means positive by positive only will be positive. That means C will be greater than 0. Are you all with me? Third one definitely true. Alpha beta is C by A. Now alpha plus beta is minus b by a. Alpha and beta both are positive. Positive plus positive I will get positive. These positive. A is also positive. A is also positive. What will be B? B value will be negative because negative into negative is positive. What is positive by positive? Positive. B is negative. What is A? Positive. Negative, positive. They are of the opposite side. So how many options are always true? 2 options are always true. A conceptual clarity on whatever we discussed in theory part. Again I am repeating, the graph is going upwards. If the graph is going upwards, A will be greater than 0. But first option is A less than 0. Eliminated. Second option, the graph is touching the axis at 2 points. D cannot be less than 0. Roots are imaginary, it cannot touch the axis. Sum of the roots, product of the roots. Both are to the right side of the axis. Alpha, beta, positive, positive, I will get positive. A will be greater than 0. C will also be greater than 0. C is greater than 0. So how many options are always true? 2 options are always true. Two options are always true. Second, one more problem. Same question. If f of x equivalent to ax square plus bx plus c. If f of x equivalent to ax square plus bx plus c. How many options are always true? First one, a greater than 0, b less than 0, c greater than 0, b square minus 4ac equivalent to 0. The graph is like this. This is alpha, this is beta. If f of x equivalent to ax square plus bx plus c, a greater than 0, b less than 0, c greater than 0, b square minus 4ac equivalent to 0. How many options? How many options are always true? How many options are always true? Only the graph is changing. Initially, first problem, the graph is going upwards. Now the graph is going downwards. See here. Listen. The graph is going downwards. If the graph is going downwards, A will be less than 0. So first one is incorrect. If the graph is touching the axis at 2 points, b square minus 4ac will be greater than 0. If it is equivalent to 0, it will touch the axis only at 1 point. This is also incorrect. Next, alpha plus beta equivalent to minus b by a. Alpha beta equivalent to c by a. Alpha plus beta is minus b by a. Alpha beta c by a. To the right side, alpha is, now first of all, the diagram is not drawn to the scale. If this is plus 2 units, this can be minus 2 units. So alpha plus beta, I will get 0. If alpha is 3, beta is minus 2. What is 3 minus 2? 1, greater than 0. If alpha is 2, beta is minus 3, I will get alpha negative. That means, since alpha beta values are not known, alpha plus beta could be greater than 0, alpha plus beta is 0, alpha plus beta less than 0. These alpha could be 3, beta could be minus 2, alpha could be 2, beta could be minus 2, alpha could be 2, beta could be minus 3. So this nature we cannot determine. A is, what is A value? A value is negative. Because if this is positive, what should be B value? Suppose, if you see, if alpha plus beta is positive, B value will be positive. What is positive into negative? Negative. Negative by negative, what it will become? Positive. If alpha plus beta is 0, what will be B value? 0. If alpha plus beta less than 0, what will be B value? Less than 0. We cannot say definitely. Sometimes yes, sometimes no. So this is not giving me are always true. Alpha plus alpha beta is C by A. Alpha beta, positive, negative, is negative. Alpha beta is negative. A, the graph is going downwards. If the graph is going downwards, C less than 0. C has to be positive. Positive by negative only I will get negative. C is positive, C greater than 0. Can it be true? Second option, B less than 0? Sometimes yes, sometimes no. How many options are always true? 1.
If it can be true, then it will be true.
Yes, if the question is right, maybe true or everything, then 2 will also come. But it is, the question is always true. In all the conditions it should be true. In all the conditions it should be true. I hope first 2 problems are very clear. It beautifully talks about the behavior of the graph, and taking the behavior of the pattern, we can say how many options are always true. Want to clear? Next.